Energy could be understood as the capacity of doing a work. Energy is never produced but always converted from an existing form to another. This is well described by the law of conservation of energy. We might find energy in various forms, each of those forms having a calculation formula. And what we learn from those formulas is that there are no change except energy going in within a form and coming out in another one. The form of energy may change in time, but the total amount does never change. When we need energy to work for us, we usually convert it from one form to another form which might be more usable. An example in this is the electric motor, in which we convert electrical energy into mechanical energy. Modern civilization is highly dependent on the capability of humans to convert energy from one form to another form. The most prosperous and technologically advanced nations are also the ones which have access to and are consuming the most energy per inhabitant. Chemical energy stored in fossil fuels is the most used source of energy. Usually, via heat obtained by burning, it is converted into usable forms of energy with an efficiency of about 90%. Using heat engines, thermal energy can be converted into mechanical energy. Heat engines have a conversion efficiency of up to 60%. Mechanical energy can be converted into electricity using electric generators with an efficiency of up to 99%. Most of the world's electricity is generated by generators connected to steam turbines using coal as energy source. Chemical energy can be directly converted into electricity using fuel cells. The most common fuel used in fuel cells technology is hydrogen. Typical conversion efficiencies of fuel cells are of 60%. A regenerative fuel cell can operate in both directions and also convert electrical energy into chemical energy. Such an operation is called electrolysis. Typical conversion efficiencies of hydrogen electrolysis is of 50 to 80%. In nuclear power plants, energy is released as heat during nuclear fission reactions. Steam is generated and drives a steam turbine, which itself drives an electric generator, just as in most fossil fuel power plants. All the energy carriers discussed up to now are either fossil or nuclear fuels. They are not renewable because they are depleting as we are using them. They are not replenished in the nature at least in an amount of time that could help us reuse them. In contrast, renewable energy carriers are energy carriers that are replenished by natural processes at a rate comparable or faster than the rate of consumption by humans. Hydro, wind, and solar energy are renewable energy sources. We call photovoltaic conversion the process of converting sunlight's energy into electricity through electronic devices based on semiconductor materials. Typical efficiency of the photovoltaic conversion is in the range of 15 to 20%. Solar energy can also be converted into heat. This application is called solar thermal energy. In addition to generating heat and electricity, solar energy can also be converted into chemical energy as well. We refer to that conversion as solar fuels. For producing solar fuels, photovoltaic and regenerative fuel cells can be combined. Sunlight can also be directly converted into fuels using photoelectrochemical devices. Electricity represents 17% of the entire world secondary energy use. Electricity is a form of energy that can be relatively easily and cheaply transported with relative small losses. It is important to note that without electricity, modern civilization as we know it would not be possible. Access to electricity strongly determines our living standard. However, today 1.3 billion people in the world, many of whom living in isolated areas, still do not have access to electricity and to clean water, primary healthcare, education, and other basic services. Changing this situation depends to a large extent on access to electricity. Photovoltaic can significantly contribute to economic and social development of those populations living off the grid. With decreasing PV prices, PV diesel hybrid mini grids attract significant attention from institutions and donors agencies in charge of rural electrification.